For this summary, I see that they're trying to remind you about mean and median, and that they're both ways to measure the center so that you're thinking of like this whole amount of data, but you're trying to kind of give a picture. We, at the beginning of this unit, we talked about typical, 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 but now they're giving us two different ways to describe the data as that center point. So they remind us that we can use the mean, which is something that kind of makes all of them balance out or distribute. Right here, it says the mean tells us that if the weights of all cookies were distributed so that each one weighed the same, that weight would be 21. So if they took all of these cookies and kind of shifted all the weight of the cookies, maybe put some crumbs of the bigger ones down with the lower ones and kind of mashed them all together, each cookie would be 21 grams. But the median tells us that if we were here, and they give us the diamond point for this, that means that half of the cookies were on the lower part where they were less than 20 and a half, and then half of the cookies were bigger or greater than 20 and a half grams. So just showing that in this situation, the data is spread very evenly, it's symmetrical. And so that means that the mean and the median are really close together. When we get to things that look like this, we have not as much symmetry. We have more of a cluster here. And when we have a cluster of data, that can change the mean and the median so that they're not that close together. Okay. In this case, it says that the median is closer to where most of the data points are clustered, because here's the median, and I forget how many cookies it says. I don't know. It says 30 cookies. Okay, so then if there's 30 cookies, that means 15 are on this side of the median and 15 are on the right of the median. So it's always showing you where where the half and half point is with how many spread. But this tells us that the mean is lower than the median because there's these lower cookies here that are really small, dragging the mean down. Okay, because most of the cookies are kind of in this range, but there's a few cookies that are kind of small. That makes the mean change from the median, and it skews that way. If we had like the opposite, if we had a bunch of cookies here and then we had really big cookies over here and nothing down here, that would probably predict that we would have a median here and our mean would skew higher because we'd have some more data that would be up here. Okay, so it talks about down below that in general, when a distribution is symmetrical, so like something that looks like this, that means that you're probably going to get the mean and the median to be pretty close. So it wouldn't matter if you described the data as the mean or the median. They're so close, it doesn't really matter. But when you have something that's not symmetrical, or they call it asymmetrical, you have to make a choice between which one describes it better. Now, if we look here, I would say that the median, describes this better because it's closer to where the cluster of the cookies are compared with this one. Okay, so you just always want to pick the one that's closest to the most amount of the data points. So next, what we're going to do is go to the cool down. I'm going to have you do the cool down on your own, and then you can check with me on the answers for the cool down. And hopefully this is making a lot of sense to you.